Hi, ClinEpi class. This is the second last part of your clinical trial simulation game, and I'm entitling this Troubled Evidence, QRPs and Other Threats to Validity, and I'm just here giving you a few hints and tips and tricks on how you might want to additionally interpret the results of your clinical trials that you conducted in last class, and how you might want to interpret the overall results. And we're going to meet up together early in next year, January, February, in order to do the final run to the finish line. So you did the clinical trial simulation, you recorded your results, you presented your results, published the results, and I've given you back the results for your clinical trials as well as for the whole portfolio, including all of your competitors and teammates' results. So what I want you to do now is interpret this in light of what we've been talking about all term. We've learned that not all evidence is equal. We know that. We know that tip of the pyramid evidence usually includes randomized controlled trials that are double-blinded or meta-analyses, systematic reviews of such. And sure, this is not a neat and tidy relationship. It's kind of more of a messy relationship in real life. But let's consider that you actually conducted randomized controlled trials. Roll of a dice is a random act. And so we're talking about your evidence being the tip of the pyramid evidence. So we learned in class about assessing risk of bias, and we talked about doing so using the Cochrane risk of bias domains or the Cochrane risk of bias tool for randomized controlled trials, where you take a look at the S, P, D, A, and R, so selection, performance, detection, attrition, reporting bias. There are similar tools, of course, for non-randomized controlled trials called the Robbins tool and the new ROBUS tool for systematic reviews and meta-analyses, though some people still use AmStar as a bit of a proxy for that. So when we're talking about assessing risk of bias, we typically think about that Cochrane risk of bias tool, SPDAR, and we insert that into those 5 questions that we ask when we're critically appraising a randomized controlled trial, or when we're critically appraising a series of randomized controlled trials in a systematic review and meta-analysis. So when we think about threats to validity, we think about risk of bias, internal validity as well as external validity combined. Now, I just want to get you thinking a little bit beyond that Cochrane risk of bias mindset, because the way that those SP, DA, and R domains are interpreted should also include some of the following interpretations. And I want you to apply this back to the clinical trial dice simulation game that you performed. So we need to think about what is a p-value, and I've given you some definitions here. So p-value, the probability that the effect size observed in the study would be this large or larger if the null hypothesis was really true, i.e. in a world really, if there was no difference between the two groups, would you get results this large, this different between groups? And if so, the results are surprising. They're incompatible with what we would expect by the play of chance alone. And in those cases, the p-value will be low. But that's what a p-value is. We also have to remember what a p-value is not. And I find that the American Statistical Society's 6 points on interpreting the p-values are really important to consider here. I'm not going to run through this because you can read it on your own. But it's something, again, you want to apply back to your clinical trial results in interpreting this clinical trial simulation. What I really want to highlight are the QRPs, questionable research practices. So I'd like you to read the Manifesto for Reproducible Science. It's available free online at the URL that I've given you here on, published in Nature. And here, this group actually put forward a manifesto for how we could and should in the future produce better research that is reproducible. And within this paper, I think they had a very ingenious way of identifying what QRPs are and how they can sort of slip into practice in our own conduct and interpretation of randomized controlled trials or non-randomized controlled trials and systematic reviews and meta-analyses. So take a look at that. Within that paper, they have this particular schematic where they highlight some QRPs, including harking and p-hacking. So p-hacking we talked about in class a little bit. We talked a little bit about harking, which is hypothesizing after the results are known. And I'd like you to interpret whether or not that happened within your series of randomized controlled trials. If yes, how did it affect the results? If no, that's great. State that and move on. We also have this issue of selective reporting and publication bias. And did that affect your results? Yes or no? You would know within your own group based on the reality of what happened. And then also surmise whether or not that might have happened in your competitors' groups when you take a look at the overall results of the systematic review and meta-analysis. And also think around issues of power. So how might low power have affected your results? How might it have affected the individual trial results as well as the overall aggregate estimate of effect? Another thing that I'd like you to think about is the fragility of conclusions in the evidence base. So the fragility index, some of you have already been using this, but do try to interpret and use this tool in interpreting the results of your clinical trials and perhaps the results of the overall systematic review and meta-analysis for stroke, for death, and for the combination of the two. I'd also like you to take a look at this article, P-values are just the tip of the iceberg. This was published also in Nature a few years ago, and it's worth thinking about because we have a lot of scrutiny on the p-value, but there is a whole below the surface part of the iceberg, the bigger part of the iceberg, which includes this trail of events that occur right from experimental design, data collection, data cleaning, exploratory data analysis, all the way to statistical modeling, inferences made, and then p-values reported and perhaps published or not in the medical literature. So I'd like you to take a look at that and see whether you could apply additionally that, if relevant, the parts that are relevant to this clinical trial DICE simulation game. Then lastly, take a look through cognitive biases and try to assess whether or not cognitive bias might have actually driven the results, yes or no. If so, which types of cognitive biases might have been more likely to affect the results? Perhaps not all of them, but there might be a couple of salient ones here that might have biased the results. If so, bring it forward. If not, that's okay too. You can state it as is. The last thing I want you to read, and it overlaps with what I've talked about in the last few minutes, but the EBM Manifesto. This is something that a large group of us were involved in creating at Evidence Live in Oxford 2 years ago. And this is worth reading because it also brings forward problems with the current evidence base and also some solutions for how we might rise above some of these QRPs and how threats to validity are assaulting our evidence base, but what we can do now that we are knowledgeable about this in order to protect the evidence base so that it is a useful evidence base to inform decision making, because that is the whole point of research, is for us to have an evidence base that is useful, valid, and at low risk of bias, so we can apply that to patients and patient populations so we know what is effective and what is not. So just a bit of a primer, go back and look through, read up on those 3 papers, and then try to figure out, did QRPs affect the results of your team's studies? Yes or no? If so, which ones? Or did they affect your competitors' team's studies? And take a look at that meta-analysis and overall results and see whether or not you might be able to surmise whether or not they did. And if so, how do you know whether or not those QRPs occurred? Or can you know? Or is it an impossible situation?